Hi everyone, my name is Leah Wasser. I am the Executive Director and Founder of PyOpenSci, and I'm going to talk to you today about some of the work that we've been doing in the packaging ecosystem. A little bit about PyOpenSci. We're building diverse community around scientific open source software, the software that drives open science. And we're doing that through peer review, training, and mentorship. PyOpenSci was founded in 2018, and we started peer review in 2019. We had funding from the Sloan Foundation, which allowed us to launch as an independent organization in the fall of 2022. This is a glimpse into our leadership team, and this slide is going to be updated over time as I build out our governance and leadership infrastructure. So today, I'm going to talk to you about the work that we're doing in packaging and our process in creating a community-driven packaging guide. I'm also going to talk about how we're using software peer review to enforce standards across the ecosystem. So my start in packaging was kind of challenging. I found it really hard to understand what tools I was supposed to use and what were the best practices. So instead of trying to fight with documentation and figuring that out, I followed a tool that I had used and contributed to. It happened to be Bioconda's, and I used their template as infrastructure for my first Python package. Similarly, very recently, I was added to the StravaLib maintainer team, a Python package, and the infrastructure was about 10 years old, so it was my job to update and modernize that infrastructure. And I tried to implement some versioning so that people could make releases, our team could make releases online. I tried to use Setup Tools SCM, and I had a really hard time figuring out how to use it. The documentation just wasn't good enough for me, and I ended up having to ask a lot of questions and then experimented with it myself to figure things out. Not exactly the ideal approach to packaging. So, in my work over the past few months with PyOpenSci, I've discovered that there are really 3 core issues, and all of these issues could be addressed. The first is documentation. The second is community engagement. And then the third is that there's a lot of competing tools in this ecosystem. Great tools, but still a lot of options. So let's talk about documentation first. A lot of documentation around Python packaging that's out there is dated, so that makes it really hard to use because it's not using modern standards. Or if it is current, a lot of it assumes some basic technical knowledge that a lot of users just don't have, and it expects users to become experts in things like selecting build backends that they just maybe don't want that level of detail and knowledge. They just want to understand how to create a Python package. And case in point, I wanted to show this comment by Justin on the Python discourse just a few weeks ago in a packaging discussion around documentation. And Justin asked, what is building and why do I care about building? Justin didn't want to know about all the ins and outs of building details. Justin just wanted to know, how do I create a Python package? Now, the second challenge that is out there is really around community disagreement. When you look at a lot of the forums, what you see is a lot of debates around things like, should we use source layout versus flat layout? Or what build backends create better distributions, source distributions, better wheels? And a lot of the time, these discussions can turn into arguments, which makes the ecosystem really seem unwelcoming, and it frankly pushes people away. Now, the thing about this is that right now, our ecosystem is not a messy ecosystem. Rather, there are a lot of really great tools out there that we could use, all of us can use right now to create a really nice Python package. But what happens is we get invested in these strong opinions. I have opinions myself. I'm part of this issue. But when they happen when we're trying to create, say, a packaging guide, we really need to do some moderation to make sure that we're not pushing people away, because there's a lot of people that have a lot of expertise that they could contribute to something like our packaging guide. But boy, if people are having arguments around details, it's going to push those folks away. So we've done a lot of moderation in our peer review of the packaging guide process. Now, finally, there are so many packaging tools out there, and let me tell you, I've used Flit, PDM, Hatch, I've played with Hatchling. There are front ends and back ends, and understanding the difference between all these tools and these concepts is really hard if you're new to this ecosystem. And so while they're great tools, it's a lot of cognitive overload for a user. What we want is early wins for users that are creating Python packages. We don't want them fighting with what tool should I be using. Again, at the end of the day, most people want to know how to create a Python package. So we asked at PyOpenSci, what if we prioritized a shared vision to support beginners creating pure Python projects? And this is where the community-driven packaging guide comes into play. The vision and scope for this is content for beginners. We have significant community input from tool maintainers and from other experts in the community, and also we need to have heavily moderated discussions to avoid some of those arguments about key concepts that really get in the way of our goal of creating this useful content for people creating pure Python packages. This is what our process looks like for reviewing sections of the guide. First, I spend some time talking with core experts and develop a small section of the guide that we can review. There is a semi-closed review process that then will get more feedback on, boy, is this heading in the right direction, or is this really not quite right, and I can make some updates. This is followed by 2 rounds of open review, and I try to get the maintainers involved. We try to get broad community feedback, and some of these pull requests are over 200 comments. So it's a lot of information to digest and then turn into these guidebook sections. Finally, the published document is a living document. So when these chapters are merged, it will be updated over time. It's not the final version. So we plan to maintain that content to make sure it is adapted as the ecosystem evolves. Now, one of the most common questions we get is, how do we pick a packaging tool? Because remember, there's a lot of them out there. And so to answer that question, I like to think about packaging in these 4 buckets. So bucket 1, create package structure. That's just creating the Py project TOML file, the README files, the license, the directories for your code, the basic structure. Step 2, or bucket 2, develop code, documentation, and tests for your package. Bucket 3, build the package. So that's creating your source distribution, your sdist, and your wheel. And those are the 2 things that you need for step 4, which is publishing to PyPy. And then if you're a scientist or someone that's creating a tool that scientists will use, we really strongly suggest that you also publish to the Conda Forge channel of Conda. So those are the 4 elements that I like to think about when creating a Python package, the 4 big buckets. Now, for a pure Python package, there are 2 approaches to this process. I like to think of the first approach as this hammer and wrench approach, this using a toolbox of tools. And those are tools that you probably prefer to use in your day-to-day workflow. So maybe you're creating your package structure manually and you might be using Bash or VS Code. You might be selecting tools that you want to use that you like. So maybe you're a Conda environment person, or maybe you're a VENV. You're probably adding your dependencies manually or with whatever tool you like to use. You can use Nox or Tox. There's a lot of them right out there. So you're picking the tools that you like. For building, maybe you're using the PyPA's build tool and setup tools as the backend, or meson-python, or maybe you're using Flit. And then finally, for publishing to PyPy, you might be using Twine. So this is a whole toolbox of tools that you select and you pull out based on what you like to use in your Python development workflows. Now, the alternative here is what I like to think about as a multi-tool. It's the one tool that does all the things, or at least a lot of the things. So PDM, Hatch, and Poetry are all good examples of these multi-tool options. PDM, for example, has an init method. It has environment support. It allows you to add dependencies and supports even lock files. It will build your packages sdist and wheel, and it will publish to PyPy. All of the things, PDM init, PDM publish, PDM build. Hatch and Poetry have similar features. These are end-to-end workflow tools. And there's so many of them. So if you're a user that wants that end-to-end support and doesn't want to deal with understanding a whole bunch of different tools, one of the pieces of our guide is a workflow that allows you to pick out what tool you might want to use based on the features of that tool. So if you need lock files, for example, maybe you're more in the web app space or doing something where you need a lock file, you're going to use PDM or Poetry because right now those are the two tools that provide that lock file for you. You want matrix environment support for testing locally? Hatch might be a great tool for you. So this is just supposed to be a helpful piece of our guide to support you in your tool development workflows. Now, finally, I want to just wrap up talking about software peer review because this is how we're really engaging with the packaging standards and trying to enforce some of those standards on community members. Not force, but just enforce and encourage use of these approaches. So our open peer review process is about providing credit for scientists that are working on software. So in the same way that they might get credit for a paper, we want them to get credit for all the work they're doing on software. But more importantly, this is about standardizing packaging and providing guidance on packaging best practices. Now notice I'm saying guidance. We're not going to force anyone to do anything specific that they don't want to. We're just trying to encourage and guide the community towards modern best practices. And let me give you an example of what our peer review process looks like. So at the very beginning of the process, we have the submission that someone would submit their tool for review, and we have initial editor checks that happen at that step that will do things like ask the maintainer, hey, why don't you think about moving your metadata from your setup Py file over into a PyProject TOML file, given that's really a modern standard right now. And so those initial checks will be really valuable for that maintainer, and we can support them with any questions that they have. Next comes the actual review, and we see that review as a conversation between the reviewers and the maintainers and an editor. And it's all revolving around the standards that we're suggesting for this ecosystem. Now, once the package is accepted into PyOpenSci, we have a partnership with JOSS, the Journal of Open Source Software. So what that means is that if it's accepted into our ecosystem, JOSS accepts our review as theirs, and it's fast-tracked through their process. So JOSS then will just review the paper for the package and accept our review as theirs. Finally, if the package becomes a part of our ecosystem, now the maintainer will have some support. They can ask questions. They have additional visibility that we provide through our online presence. So there's a lot of value added to becoming a part of our ecosystem. I want to just show you what a process looks like a review. So this is a GitHub issue. You can see it's PyGMT is the package name. And what's important about this image is that you can see the editor name, you can see the reviewer name, you can see the version that was accepted, the date it was accepted. So this is the metadata, and the entire review happens on GitHub. So it's in the open. Anyone can see the conversation that happens associated with that review. Finally, I want to just mention that this is one package that was recently accepted by both PyOpenSci and also JOSS. And Pythony is a great example because in that case, we were able to encourage the author to move their metadata out of that setup Py into the PyProject TOML to update their documentation infrastructure. And this package happens to be a Bioconda package, so the Bioconda channel of Conda. And we helped with some installation issues that were also happening across operating systems. If you want to check this out, you can go to github.com, PyOpenSci/PyOpenSci, and go to our software review repository, and it's issue number 65 if you want to just look at the pre-submission inquiry associated with this and how things evolved through this conversation. This is our editorial team. Our editor-in-chief, David Nicholson, has been doing an amazing job, and we're growing our editorial team. So if you know of anyone that might be interested in joining us and participating in the review process, we welcome you to get in touch with us. And then finally, I need to mention that we are all about community, and we're trying to build this diverse community. We're trying to make sure that we're including lots of different people, different backgrounds, different gender identities in our community. And so as such, we're partnering with different organizations, from Scientific Python to the Journal of Open Source Software, Open Science Labs, ROpenSci, Pangeo, and maybe your organization, if you're watching this and you have some interest, could be our next partner. We really want to partner with folks that are doing great work in this community. So with that, I'm going to wrap things up. Thank you so much for listening to my talk. There's lots of ways to get involved with us. If you're interested in becoming a reviewer or maybe an editor for us, you can sign up on Discourse to get some of the latest updates and what we've been working on. We're on Twitter and we're on Mastodon, so that's also a great way to keep in touch. And then my email, leah@pyopensci.org, if you want to reach out to me specifically. Finally, I have to thank the Sloan Foundation for providing funding to support our effort. We're just so grateful for that. And thank you so much for listening today. Reach out if you have any questions. I look forward to hearing from you.